we will discuss ScalarDB APIs in this video. This is a conceptual diagram of ScalarDB. The storage abstraction layer absorbs differences in storage or databases, and thus enables transactions between multiple types of databases. The transaction manager is configured on the storage or database abstraction layer. This makes it possible to handle different types of databases in the same way. It also makes non-ACID compliant databases ACID compliant. ScalarDB is middleware written in Java code, and the actual data is stored in storages or databases registered in ScalarDB. There are two main usage patterns for ScalarDB. The first is to embed ScalarDB in a client-side application. Communication between ScalarDB and the database is done using database-specific protocols. The second option is to use a ScalarDB cluster. ScalarDB cluster is a clustering solution for ScalarDB that consists of a set of cluster nodes. When using ScalarDB cluster with a client-side application, you can use the ScalarDB client SDK. It is the same as embed type. Communication between ScalarDB cluster and the database is done using database-specific protocols. Communication between the client SDK and ScalarDB cluster is done using gRPC. In this session, we will discuss the pattern for embedding ScalarDB in client-side applications. We will discuss ScalarDB cluster in another session. ScalarDB Java API consists of two API groups: Administrative API and Transactional API. Administrative API provides defining database objects such as namespaces, tables, indexes. In this course, we will use Schema Loader tool instead of calling each administrative API. The Transactional API provides the ability to manipulate insert, get or scan, update, and delete records, as well as control transactions. During the course, we will explain an example of a get operation using the Transaction API. Now we will discuss important steps to be implemented when using Transaction API. Get a distributed transaction manager instance. You first need to get a distributed transaction manager instance to execute transactional operations. After you have executed all transactional operations, you should close the distributed transaction manager instance. Begin or start a transaction. Before executing transactional CRUD operations, you need to begin or start a transaction. Implement CRUD operations. We will describe key construction and CRUD operations in the following sections. Commit a transaction. After executing CRUD operations, you need to commit a transaction to finish it. Roll back or abort a transaction. If an error occurs when executing a transaction, you can roll back or abort the transaction. Here is a simple sample code that corresponds to the APIs mentioned above. Get a distributed transaction manager instance. Begin or start a transaction. Implement CRUD operations. Commit a transaction. Roll back or abort a transaction. Close a distributed transaction manager instance. In this session, we discuss get operation only. We will discuss other operations in building application sessions. First, you need to get a distributed transaction manager instance to execute transactional operations. To get a distributed transaction manager instance, you can use Transaction Factory. After you have executed all transactional operations, you should close the distributed transaction manager instance. Before executing transactional CRUD operations, you need to begin or start a transaction. Alternatively, you can use the begin method for a transaction by specifying a transaction ID. Specifying a transaction ID is useful when you want to link external systems to ScalarDB. In get operation, you create a get object first, from a get new builder, specifying namespace, table, and key. And then you can execute the object by using the transaction.get method. The get operation returns result objects. Finally, execute the commit method, which coordinates the transaction. If an error occurs when executing a transaction, you can roll back or abort the transaction.